The area under the normal curve can be used to model the probability histogram and the actual proportion in a given interval. So we're going to work on that next. Suppose that a random variable x is normally distributed with mean mu and standard deviation sigma. The area under the normal curve for any interval of values of the random variable x represents either the proportion of the population with the characteristics described by the interval of values, or the probability that a random selected individual from the population will have the characteristic described by the interval of values. So basically, when we find a shaded area underneath the curve, it's a proportion or a probability. Let's look at an example. The serum total cholesterol for males 20 to 29 years old is approximately normally distributed with mean mu equaling 180. So where does the mean go? Right in the middle. And a standard deviation of 36.2 based on the data obtained from the National Health and Nutrition Examination Survey. Draw the normal curve with the parameters mu, which we just did, mu minus sigma, and mu plus sigma. So that would be mu minus sigma is 143.8, mu plus sigma is 216.2. B, an individual with total cholesterol greater than 200 is considered to have high cholesterol. Shade the region under the normal curve to the right of x equaling 200. So these are x values, correct? X is equal to 200 is where we need to plot. So where does 200 lie in here? Somewhere in between 180 and 216. And then to the right, so shade to the right. Part C, it says, suppose that the area under the normal curve to the right of x is 0.2903. So we have a proportion of 0.2903 of this occurring. We'll be able to figure this out in less than 7.2 and then provide an interpretation. So there's actually two interpretations according to this book. The first one is the proportion of 20 to 29-year-old males that have high cholesterol is 0.2903. Second interpretation, so we just did the proportion, now do the probability interpretation. So instead of proportion, we have probability that have high cholesterol is 0.2903. So the probability and proportion is going to be the same of 0.2903, just different words. Just know that sometimes they can be expressed as a percentage, but in Pearson we're going to be expected to do it as a decimal.